Hello everyone, this is Pavithra, Assistant Professor, Department of ECE, SNS College of Engineering. Today's video we are going to solve the second problem. In the last class we have derived the first problem, that is the frequency response, current and the voltage drop across the inductor and VL and the quality factor. So each and every class I am explaining what is a resonance frequency and what are the things and all, because it should be get it in your mind and you have to keep a reminder. So the frequency response is nothing but the natural frequency, right? So in the fourth unit we are discussing about the two things. One is the series and another was the parallel. In the series, these are all the series circuit, and the parallel, the last two videos before I have solved two problems in the parallel resonance. Now I am going to solve this problem using the formula, right? So first of all, in this question they have given me resistance R is equal to 10 ohm and the L is equal to 0.04 H and C is equal to 1 microfarad. So how can we draw this? How can we draw this circuit? So first of all, it will be a resistor, so that will be a 10. Next there is an inductor. Inductor we have to put like this, and then there is a next one is a capacitor. Okay, and they have given like this only. Okay, they have not given any voltages and all. We can simply mark it as this value, resistor is equal to 10 ohm and the inductor is equal to 0.04 and C is equal to 1 microfarad. Okay, these are the values they have given. So what we are going to find it here means, one is a quality factor, another one is a bandwidth, next one is a resonance frequency, next is a half power frequency, then one is half power frequency. In the half power frequency we have two formulas. One is for F2, another is for I1. Okay, then F2, another is for I1. So we have to know what is the formula for the quality factor. So we have discussed this here. The quality factor formula is omega R L divided by R. Why we are using this formula means because our problem is based on the frequency response. So we got it as a frequency response. So only we are using omega R L divided by R. Omega R L divided by Fr. Then the omega R is nothing but 2 pi Fr. So the Fr is we are deriving here. So we are using this formula. But in this problem we are using the different formula of the quality factor. Quality Q is equal to 1 divided by R root of LC. 1 divided by root of LC. So we know what is the value for the R, it is a 10, right? So 1 by 10 root of, what is the value for L? 0.04. Here they have given the Henry, you don't want to use any 10 power value. And here they have given microfarad. Microfarad is nothing but into 10 to the power of minus 6. So we are using what is the value of here 1, here it is a 1, so 1 into 10 to the power of minus 6. If you put it in the calculator, first you have to find out the root of 0.4 divided by 1 into 10 to the power of minus 6, and then you have to multiply it with 1 by 10, you will get it as quality factor as a 20. So this is the first thing we have derived here. Next one is a bandwidth. So you know what is a bandwidth. Bandwidth is nothing but, see, if I have a sinusoidal waveform like this. Okay, what is the meaning of bandwidth means? See, from this here to here, what is the value? That is called as a bandwidth. So here what is happening? Here we have a higher end, that is a F1. Here we have a lower end F2. So that what we have derived as F2 minus F1. So what is how to find this bandwidth means, we have to find the F2 minus F1. So bandwidth is nothing but the definition means the difference between the higher cutoff frequency to the lower cutoff frequency. So F2 minus F1. So F2 F minus 1, we don't know the formula for F1 F2. So we are using, what is the formula for this bandwidth is R divided by 2 pi L. Okay, so R is nothing but the 10 divided by 2 pi into, what is the value of L? 0.04. So 10 divided by 2 pi into 0.04. So if you substitute this value, you will get it as 39.78 Hz. Okay, so what is the difference between this is, Here we are using the frequency response and then we are deriving here. Here they have directly they are asking the quality factor. So we are using 1 by r root of LC. Okay, and then the bandwidth. Bandwidth is very important. The bandwidth formula is upper cutoff frequency minus lower cutoff frequency and the resistance divided by 2 pi L and 10 divided by 2 pi into 0.04. Okay, that is the value. Then next one is we are going to find out the very important thing. It is a resonant frequency. Okay, resonant frequency Fr is equal to, we have derived already, Fr is equal to 1 divided by 2 pi root LC. Okay, 1 divided by 2 pi root of 0.04 into 10 to the power of minus 6. Why we are using this? Because of microfarad. Okay, 0.04 into 10 to the power of 6. We have to find this one. Okay, then next one is a next one. So this value is 795.77. Okay, this one. Then the half power frequency. The half power frequency is F2 is equal to Fr minus R divided by 4 pi L 795. If you this Fr is nothing but 795.77 minus 39.78 divided by 2. So R is we have substituted the value here, and if you find this difference, you will get the F1 frequency. Sorry, this is F1 and this is F2. Okay, and then half power frequency F2 is equal to if 1 means minus 2 means plus, because it is a upper value and it is a lower value. So we are using this minus formula here in the plus formula here. Fr by R divided by 4 pi L, and if you substitute this value here, we have directly substituted some value and have some derivation here. After that only I got it as 13.78 divided by 2, 13.78 by 2. If you add this value, we will get it as F1, F2. So totally what are the things that we have derived? Quality factor, bandwidth, resonant frequency, half power frequency F1, half power frequency F2. I hope you understand this problem. In the next class we can see the unit 5 and we can derive the problem, and thank you all.